This is Senator Gene Yaw. Today, we hope to show you something unique about Central Pennsylvania. We're at Gilson Boards, and they make snowboards. I'm with Nick Gilson, the inventor of the Gilson board, and I hope that you can tell us a little bit about how you got started, what you're doing here manufacturing snowboards in Central Pennsylvania.
Yeah,
it's a little bit unusual, and I know that you have a pretty unique design, so we'd like to talk about that if you could tell me about it. And we can start with this board, or whatever you call it at this point, and kind of explain it so that the people can get some feel for the technology involved in your board and what's behind it.
Yeah, absolutely. Well, first of all, thank you for being here.
You're welcome.
This is all Pennsylvania poplar here. And what we're looking at here is actually a board we've never tried this before. This will be the thinnest, most flexible board that still will not break, assuming all goes well. But we can absolutely walk through the whole process and take a look at how our boards are made, and we can also talk a little bit about what we're doing here.
Where did this wood come from?
Right down the road. It's all Pennsylvania poplar.
Just out of curiosity, I mean, this is pretty thin and it's flexible, and how do you get it this thin, or what process do you use to get it to this point?
Absolutely. So we first start with a planer, and we'll actually take it down to a flat, thin core, which is the thickness of that is defined by the thickest point on the board. So we'll start by taking this wood and making it totally flat and uniform on both sides, and then we'll put it in a jig that we've fabricated with our CNC robot, and then that will put in a wave profile in the surface so that it is thicker where your feet go, and thinner at the nose and tail, and thinner actually between your feet, which allows the board to have that localized flex while riding. We will then take the board and flip it over, set it into a jig on the CNC, and then we will, to 2/1000ths of an inch accuracy, machine the base of this board. And the reason why we do that, and why we have to do that, other manufacturers do not, is that we actually have a three-dimensional base technology, and those contours in the base are actually in the core as well. It's not just molded plastic. It's the actual wood core. Embodies that contour as well.
Now, I know that this particular piece is shaved off of a block that's made for you. Is that right? Is that kind of how it's made, how it's done?
Yep.
I mean, these are individual boards here.
Correct.
That are glued together.
Yes.
And then you shave this off, or have somebody do it for you?
Exactly. So we'll first start by taking 15 8-inch wide blocks of poplar. It's actually at Stanley, and Stanley will sort for a high-end pool table manufacturer, or they'll sort for Gilson Boards. And so the poplar goes through their facility. They just glue it up for us into what we call a big core block. And then that core block goes and gets cut into what we call core blanks. And the core blanks, about 12 to 13 core blanks out of a core block. And we take a massive bandsaw that actually sits on a trailer, and just down the road from where we are right now. Normally used for resawing of large other Pennsylvania trees, but they'll use it to just slice sections off of that block, and then each one of those ultimately becomes a snowboard.
Maybe I should have asked you initially, how did you get to Pennsylvania to manufacture snowboards?
It's a fantastic question. The story actually begins in Nashville, Tennessee, most unlikely of places, but I was teaching science with Austin Royer, who grew up about half a mile up the road. The Royer name is well known in this area. And he and I had started teaching the kiddos in Nashville, and year one was crazy. It was 100 hours a week, just trying to get these lesson plans right and interactive, keep the kids engaged, keep the kids learning. They started at under 20% proficiency when we started with them, and by the end of that first year, they had gotten up to high 80% proficiency as a group. And so we knew that we still had room to improve and things that we wanted to do in the classroom. But we also had lesson plans that were already done. And so we, not a tremendous amount of free time, but we did have some free time each day after school to actually go and start building a shop. And we did that in my basement crawl space, probably not a space that we were supposed to be in, was not part of the lease, but we'll keep that. But so we started basically building a small shop in the basement, bringing the prototypes into school and working with the kids. And the first iteration of this design totally tanked. It was awful to ride it. I stubbornly rode it for a full 4 days, and but it was.
I think you described it as like trying to ride a canoe down a hill.
Yeah, that was also his description. He described it as trying to ride a canoe down the mountain. But so at that point we probably would have tossed in the towel. But the fact that we had all of these students looking at us and we'd told them multiple times that there's a lot to be learned from failure. And so we committed to reinvesting into this idea and continuing the design process.
How did you get here?
Then we went and tested. We had proof of concept by March. We were like, okay, we're going to start a company. We're going to Colorado. And then we started to think about what actually entailed to start a company, because that was something that we really hadn't intended to do. We realized that rent and overhead were a big part of it. Austin grew up about a half a mile up the road, and so we went and checked out his space, and we had this barn on his parents' property that we shared with donkeys and horses for year one. And so we were basically manufacturing out of a stable to get our minimum viable product out. We then toured, and at this stage we were still saying stuff like, yep, this is a great place to start, but we're going to move closer to the Rockies or wherever it was. At this stage now, another full year after that, I can tell you with complete certainty that we will never leave this state for manufacturing.
Well, I mean, that's really great to hear, and it's also great to hear that you're using Pennsylvania wood.
Mm-hmm. Yep.
And this is really unique, and I know you have a couple of boards here where they're finished, and we'll get to them, but they're very, very attractive, and I think as you pointed out, since you're dealing with wood, every board is different.
Right,
it's unique.
Exactly. And we, as we sort for this, we do it completely random. So each board, the poplar is not a totally uniform color. So you'll see that in some boards, but not all boards, there'll be dark purple or a darker green color that will be visible in the final product.
And I also noticed that eventually we might be able to pick up your original board. The weight between your original canoe and this is pretty significantly different.
Yep, absolutely. As is the flex.
You said about the flex, and that's one of the things that's unique about your product here?
Well, the thing that's unique about it is that with this bottom contour, you've got these S-curve ridges that go across the base. And so what was initially making that first round prototype so stiff, by thinning out the middle here, this is where we almost tossed in the towel. We thought we wouldn't, with this base contour, we would not be able to design a board that was flexible enough to be appealing to the average rider. But what we found out is that much like the ridges on a tin roof or the corrugations in cardboard, when you add these S-curves in that triaxial fiberglass, it really increases the integrity of the board. It makes it significantly stronger. And so not only is it stiffer, it's also stronger. So what we were then able to do is really thin it out. And when we did that, we created a product that was incredibly flexible, but still very strong.
And all your boards have a metal edge on them too, right?
Yep, that's correct. Yep.
Okay.
And that's actually lifted up just off the snow a little bit, which is very unique to our design. The standard snowboard in almost all cases is totally flat across the base. What we've done is you might be able to see it better on this board with the color, but what we've done is we've basically got a channel down the center, and you've got a soft edge and a hard edge out here on the sides. And the idea is that when you're riding on hard packed snow, you will plane up onto these low surface area rails here, break contact in the middle, which drops your drag coefficient, take your steel up off the snow, which then drops your coefficient of friction, and those together will allow you to accelerate over 20% faster than the standard board, 26% faster to be specific. But when you then hit powder, you want a lot of surface area and that light snow to lift you up and allow you to float. And a skier will switch from their real narrow race skis to their big fat powder skis. With this technology, you just sink in very slightly, make full contact across the width of the base, and you've got all the surface area needed to lift you up and allow you to cruise in powder.
This is a multiple surface board.
Yes, exactly. And you know what's interesting is that between, you know, it's a very subtle contour, but there are incremental surface areas between the two extremes, which means that your board will raise and lower without, you know, without the rider's input. It will raise and lower to just give you that ideal surface area based on rider weight, velocity, snow condition, density, all of that stuff. So,
well, these boards are very attractive. Can you show us a little bit more about how you put them together? And
yeah,
absolutely. I know
absolutely.
some of your process are proprietary and we won't go there, but we'd just like to see how you put them together, because they're very attractive and pretty unique.
Fantastic, sounds good. Our boards start like this, and this is, you know, a full 12 snowboards inside of this core block that will then get sliced and turned into core blanks like this. The next step in the process is they come over here and they get holes drilled and they go on a CNC robot, and that cuts out the sidewalls, where we then go ahead and glue in the different color sidewalls, either green, pink, wood, or black. And these sidewalls then are basically the hydrophobic barrier to make sure that no water gets into the finished product. The boards then come, after they've got sidewalls in, to this planer. And when they go through this planer, they are planed to a flat thickness first, just to make sure they're totally smooth and uniform on both sides. They then go on top of one of these jigs that we've cut to 0.02 of an inch accuracy with our CNC. And then using a couple of creative mathematical tools, we've been able to figure out how to take the diameter of that wheel passing over this shape to then create a different shape on top of the board, which is what gives it that top profile.
The wave.
We're very lucky to work with a super smart mathematician who, he and I crunch some numbers and usually get it wrong once or twice, but that's the beauty of empiricism. And that's also the beauty of having a quick turnaround. You know, when we make a mistake, we generally know within the hour. This is a board that has just been cut out here. So you can see in this state, the snowboard's actually very fragile. This is the engineered waste from the core, and you can see that while still being quite flexible, it will eventually break. And so it's important to protect the core of the board with the triaxial fiberglass, and we'll get there in the next room. But this is basically where the proprietary aspects of the design, or the unique aspects of this design, really start to take shape. You'll see up until this point, it really, you know, we could be a furniture manufacturer, but once the piece comes off this table, it's a snowboard, and it's not only a snowboard, it's a Gilson board. It's got that base contour in it.
Oh, I see you have the pegs here, and they fit within those holes, I guess, when it comes off. So
exactly.
it sits down on it.
This peg system is a relatively simple solution to a somewhat complex problem, and that is, how do you machine accurately in multiple different places in the process, in the exact same place, relative to the other places that you're machining. And so these 4 peg holes are outside of the actual board and will eventually be cut off, but these 4 peg holes mean that everything that happens to the core happens in the right place relative to these peg holes, which makes sure that every board comes out exactly how we want it to.
Good.
And a snowboard is very much like a sandwich. You've got your plastic base, which is 4001 grade sintered PTEX, and you can see that that's what this is here. This is the highest grade PTEX that you would see on the commercial market. It's not cheap, but it's really, really durable, and it's quick too. You can see that, I have to clean this before pressing. You can see that one of our guys has already gone ahead and taken this steel edge that starts on a spool.
The steel edge.
Yep,
okay.
and we just basically come in and we tack it down onto the shape of the base layer. And then once this goes to the press, it will be wetted with fiberglass. Then the core will go down, another layer of triaxial fiberglass, any logos that we're putting on the top, and then the clear top sheet, and then it will go into the press to bake for about 25 minutes.
But still, the key is the wooden.
Absolutely.
The
exactly.
core, the wooden core.
Yep, and so the core of this snowboard is actually what gives it its final shape, that coupled with the press.
Okay.
So you see that we've got different jigs here that are used to make our different size boards, both men's and women's. This is, over here, just so you know, this is triaxial fiberglass, and triaxial fiberglass is incredibly strong. Obviously, it's just a cloth right now, but once it's impregnated with epoxy, the two will work together to make an incredibly high-strength composite. that allow for flex, but also high levels of structural integrity. This is our graphics department right here. This is just a test print here, obviously, but essentially what we do is we do sublimation graphics. So we'll use that large format Epson printer over there to print out onto a waxy-like paper, and what that does is it allows the ink to sit on top of the paper without being absorbed into it. Then we lay a piece of plastic down on top of it, stick it into this press, cook it at 330 degrees Fahrenheit for about 9 to 10 minutes. And then when we pull it out, the ink has sublimated off the surface of the paper, risen into the plastic, and been trapped in there. And so now this could be the base of a snowboard, although this is obviously just a test print.
Is that what some of the, you indicated earlier, some of the boards actually use a fake wood design on them?
Yeah, that's how you do that.
That's how you do it.
Yep. Yeah. If you can tell, if you look at a whole fleet of a company's boards and every single one of them has the exact same wood grain, it's been printed.
Yeah.
Yep.
Well, that's a good point.
Yep.
Because all wood is a little bit different.
And probably many, many miles away, across the pond, as they say. In here we've got our pressing room, and this is sort of where the magic happens. The layers, there's been a lot of time and a lot of effort put into getting the layers of the piece correct and manufactured properly. And then when they come in here, the pressure's really on, no pun intended. But we lay down the base, then we lay down the fiberglass, wet the fiberglass with epoxy, wood core, fiberglass top, graphics, plastic. Do that all in less than 20 minutes before the epoxy starts to set. Flip it over, stick it in the press, inflate this guy, or one of the cavities, whichever one it's going into. And that will apply 80 psi, or roughly 60,000 pounds of pressure across the surface of the board, and it will cook it at 180 degrees Fahrenheit.
How long does that take?
24 minutes. At room temperature, epoxy takes roughly 12 hours to cure, and so this speeds it up from 12 hours to 25 minutes.
Well, now you've taken us through from the start and how they come out of the press and the benefits of your particular board. How are you marketing them? What are you doing?
That's a great question. The biggest piece, and at least the most fun piece of our marketing plan, is that our core team, we're really, we may pride ourselves on liking this science and enjoying the manufacturing process and all of that, but at the end of the day, all these guys, including myself, are just snowboard bums. So we pile into that Airstream trailer outside, and we bring the 2 border collie dogs and 5 of us, and there are a couple of us that stay. We rotate. A couple of us stay back here to make sure that the fort's held down properly and that we're still producing boards that are up to our quality standards. But then the rest of the team is on the road. We travel 17,000 miles over 5 months, working with our affiliate mountains as far east as Maine and as far west as California, and a lot of places in between.
I saw on your website you have a listing of the places that you're going to be visiting and stuff, and it's virtually all over the colder part of the United States, I put it that way.
Yeah.
Because snow is necessary.
Exactly. Many of those places are at altitude too, which the Airstream is a beautiful, beautiful trailer, but it needs a little bit of retrofitting for you to be able to wake up happily at 10,000 feet, at 10 degrees outside. We need to turn it into an igloo a little bit, put some insulation in there in a few places where it doesn't come standard. All right. This is actually the original board right here.
Oh yes, we talked about that.
Right. This is the Gen 2. This is Gen 2. The original board I built when I was 14. It looks really nothing like anything we produce now, but it has I guess the most core concepts in the design are visible. But this is obviously very drastic. This is almost 3/8 of an inch to a 1/2 an inch here difference between the regions. We're now down less than a 1/16 of an inch in contour, and we found that that's enough. Yeah, this is a canoe that looks like a snowboard. It does not flex at all.
You said you started your first board or built it when you were 14?
Yep. Yeah, I was building surfboards back when I was 14. It's actually how I got into surfing and snowboarding. Well, at least with surfing, wanted to try it.
Are you going to branch out into surfboards?
No, probably not yet. At least maybe in the future. Who knows? I think that we won't enter the surf market unless we've got something really new to bring to the table. But we'll let the current professionals.
And obviously, the Gilson boards that you're building now are new and they're unique.
Absolutely, and that's sort of the name of the game for us. We're not going to just enter an industry to push paper and make money on the business deal. We're really interested in shaking up the way things are done. And it's not that things are done poorly, it's just that you know, there's always room to improve, and anybody who tells you there's not in anything is full of it.
We're now joined, Nick's had some of the employees and inventors and helpers and everything else join us here. So if you would introduce them, Nick, and we're also joined by Don Alexander, who's the Director of Economic Development for Union County. Can you tell us a little bit about the impact of this small business here in central Pennsylvania and what it does for the community and just this area of the state?
Well, first and foremost, Senator, it really speaks to the business-friendly atmosphere that we have here in central Pennsylvania and the ease with which entrepreneurs such as Nick and Gilson Boards can start up a business here. But more importantly, you know, one of the things that has come out through our tour here today is the effect that Gilson Boards has had on other businesses in the area. For example, the wood harvesters that supply the poplar and the wood manufacturing companies that do the blank cutting.
Well, the most interesting thing is that Nick said that they're here for the long haul, so I really appreciate that part.
I appreciated hearing that as well.
Nick, if you would, could you introduce some of your crew here?
Yeah, absolutely. These guys are the ones who really make it happen. You know, we've learned that the idea itself accounts for we thought initially less than 10%. Now it's clear that it's less than 1% and still dropping to bring a new product to market. Yeah, the idea is important, but it's the people and the effort that you put in post idea that really makes or breaks it. And so this is Wes here. Wes is one of our recent additions to the team. He's a shaper and has been absolutely killing it lately, producing some beautiful stuff. Danny is the one who takes responsibility for Danny Jones right here. He takes the responsibility for most of the really cool innovations and process that you see in this shop. I mean, he's the one who's responsible for the router jigs and the design of basically how to take materials from the raw state to the finished state quickly, and the key point is quickly. Max, he's also an unbelievable snowboarder, and so he's test pilot #1 as well as
So you get to test all this stuff first.
I get the fun job.
Oh, wow. Next to Danny is Max. Max is the creative director, so to speak, which is a title that he completely fills and then much more as well, because that's not really encompassing of what he does entirely. He's full of lots of funny puns, but he also wears a lot of hats. You know, he takes care of business in the shop. He takes care of business in the office. He makes sure we continue to operate as a company. And then Aquil, to his right, is another one of our recent additions to the team, and he is a fantastic shaper as well, who's added a lot in the shop, and both in terms of production. But you know, the unique thing is that these guys who come into the shop, they come in as not line workers in manufacturing, right? That thought, I think, is or that type of role is no longer useful in manufacturing. I think it's much more important to have people who come in who understand a process from start to finish, and who can then have the authority and ability to say, there's a better way to do this. We can change this. And the more people you have in the shop with that level of autonomy and authority, the better. And both of these guys, Wes and Aquil, have joined the team lately. And had you been here 2 months ago before they got here, this place would have looked different. You know, so not only are they producing great boards, but they're also changing the way in which we make them.
Well, I think you guys can all be congratulated. I mean, I'm not a snowboarder. I don't know that much about snowboards. But one of the things that's pretty obvious from just looking at it is you produce a product that's almost like a work of art. They are really neat. They're really neat, and I think that most people, I recognize the quality, and you can be very proud of that.
Thank you very much.
Yeah,
Thank you,
you're
Senator.
welcome. You indicated, Nick, that you're in Pennsylvania for the long haul. Mm-hmm. What's unique about doing business, especially in a small area or rural area in Pennsylvania?
You know, it really comes down to the fact that people here, you know, we just take care of each other. That's what it's about.
How do you do that?
Yeah, you know, when we need something welded in our facility, or when, you know, we're fabricating a new machine and it requires people with serious skills outside of the ones that we have, you know, very much in house. we're able to trade for that. We don't have to hire. You know, we walk down the driveway and we go over to Larry Royer's house and we say, "Hey, Larry, you know, thinking about building a new hydraulic press. What do you think?" He says, "Well, I got some wood to cut."
And you cut the wood?
Yeah, and so we'll use the log splitter and cut the wood and make him, get him all ready for winter so he doesn't have to do it. And in return, he'll, instead of dinging us $150 an hour for welding, he'll, come and take care of us and help us weld up a new press. And so there's this, not only are those people there that are capable of doing these, really impressive things in manufacturing, but they're willing to trade and they're willing to just help out for the sake of, them wanting to see us succeed, which is cool.
Very good. That is something that's very unique, I think, to rural life, especially rural life in central Pennsylvania.
Yep. And, now I know how to bale hay as a result. Yeah.
One part of the team that was busy when we were talking to everybody else was Hannah. Mm-hmm. What's your job here?
I'm the tour event manager here for Gilson Boards. I came on tour last year. I'm from Nashville, Tennessee. It's where we all met each other. And I came on tour last year, had an amazing experience, learned how to snowboard, and decided to hop on board for this summer and coming up winter season. So, booking it all, I know what to expect, So I figured I'd be the best one to do it.
What's your job? Are you part of the fabrication, or is it marketing, or what? Where do you fit into this?
Yeah, I guess marketing side of things. I just have I'm the main communicator with the mountains that we demo at, and kind of organize our coast-to-coast tour this coming up year.
I noticed that. Where will you be going? We talked a little bit about it.
We're starting the East Coast, so we're going to start with New York, and then we go all the way up to Northern California, and then we end up, I think we changed it up a little bit recently, but I think we're going to end up in Washington, and then make our way back home to Pennsylvania here in middle of April.
And snowboarding all along the way.
Snowboarding all along the way.
In the Airstream trailer.
In the Airstream trailer.
Hannah's done some good things for us. Last year's tour looked like, if you look at the map of last year's tour, it's a big zigzag all around the country, and Hannah's made it a streamlined flow throughout the continental U.S. So we're very thankful for Hannah's work.
Well, thank you. It's very nice to talk to you.
Great to talk to you too.
So what we're doing is we're building a prototype board.
Yes. Do you want it on there like that? And this is just a temporary protective layer that'll come off after pressing, just to keep epoxy from getting on the base. Senator, would you like to make a snowboard?
I certainly would. What do we do?
So we'll just spread this all across the base and make sure that the edges of the metal is completely saturated. And then once we are done with that, we will add this rubber tape. So squeegee, want to grab squeegee? And you just kind of move it around, make sure the whole base is just painted with it.
Out to the edge?
Yep. You've done this before.
It's better at it.
Got a second career. Yes, he does.
You want a job? Building snowboards is very much artisan thing. It's all handcraft for the most part. There's even a few steps, there's no way around it, You have to have the work, which is good, because, snowboard deserves some love,
I don't think I've ever been referred to as an artisan. So we have to put this on.
Where it's good, maybe. Yeah, that's what I was thinking too.
Am I cleaning your hands there, Wes?
Mine, they were clean about 2 seconds ago, but I can.
Do these get epoxy on the outside of them or not?
Yeah, the epoxy will saturate through. This is the top sheet of the
Good on your end?
Wow, look how that came out.
Oh yeah. It's pretty impressive how vivid some of this becomes. again, as I said, since we press with so much pressure, if there's even like the tiniest speck of dust, it'll cause an indentation in the plastic. So we gotta be careful with that. This is to help protect the press, as well as apply a little bit more uniform pressure across the surface of the snowboard while it's in the press.
Will this one break, or will this one become like part of your permanent archive?
My guess is, seeing how thin that thing is, that's going to be Danny Jones's personal board this winter. But yeah, this one won't ever leave our control. We wouldn't sell this one.
Since you said you're the chief test pilot here, what do you think of these boards, and why are they different?
For sure. Well, we prefer the term guinea pig, but I think they're great. You know, I've been riding for snowboards for 16 plus years, and I've ridden all sorts of different types of boards. And these boards are incredible in the sense where, you know, we could have a flexible board and it still maintains its pop. Typically, you would have like a soft board. It'll be a little washy on you, not as responsive, no pop. But you'll be able to like press out a nose press, super easy. You know, ride in powder, super easy. But you lose a little at the same time. While these boards, they can maintain their strength, they don't break on you, and you maintain your pop. The other turn at the other side, if you prefer like a surfy ride, it allows you to be able to do that as well. You can really get like another dimension of feel, you know. So rather than just having like one standard way of riding, you could almost explore a whole new way. So it's really fun.
Thank you.
Yeah, of course.
Yeah, Danny's been adding new tricks to the repertoire daily. It's pretty cool. It's such a new design. It's such a new way to ride that one of the coolest things for us, well, at least for me, is because I'm better at building them, I think, than riding them. You know, I love to ride them. I count myself to be a good rider, but nothing like Danny. You know, and so see people like Danny and the people that we meet on our demo tour who take this technology and do things that people have never seen on a snowboard before. That's really cool.
If any of the people out there that are watching wants to buy a Gilson board, how do they go about doing it?
Oh, well, good question. We are just moved into retailers here in Pennsylvania. There's a place called Timber Skate Shop down the road that's doing some really neat stuff. They're in Sunbury, and then on GilsonBoards.com you can get any of our production models and actually customize your own board as well. And so it's GilsonBoards.com, GilsonBoards.com, Yeah, it's a cool website. It allows you to basically go through and look at the different models and shows you what each model does, and then the custom one's the cool thing. You know, we've had people who do everything from putting their own face right on their board.
Oh, really? I guess you could do that.
You can do anything, yeah.
Okay. Well, thanks a lot. We've really enjoyed learning about snowboards, and especially snowboards in central Pennsylvania. That's pretty unique.
Yeah.
So thank you.
Well, thank you. There's we've told each other before, there's no place, we don't think there's a single other state in the country that would have let us get this far. So thank you for what you've done to maintain this climate, because I think it's been the make it or break it for us.
Well, we wish the best of luck to you, and I know you need a little bit of luck, as well as good design and good manufacturing and everything, but that always helps.
Yeah, exactly.
All right, thank you.
Thank you again.